All right, here we go. There is your homework for tonight. Today we're going to be doing problems involving something called a locus. Maybe you've heard this word, maybe you haven't. In fact, if you've heard this word, you might be thinking about, oh, by the way, this is going to be the quickest class of the year. You may have heard that word locus before, and you may be thinking about that thing.
The UN is appealing for more than $41 million to eliminate a severe plague of locusts in Madagascar. Half of the money is needed by June to try to save the country's crop production. Around half of Madagascar is currently infested, with each swarm made up of billions of insects.
Crazy, right? This has nothing to do with the math thing. I just want you to understand this is a different word, locust, with a T. Piece of trivia here. If you had a square kilometer of a locust swarm, it would eat as much food as 70,000 adults would eat each day. So that's why when a locust swarm hits, you're left with no vegetation. They eat everything. All right, today we're not doing locust with a T, we're doing locust without the T. And locust without a T is a math concept. So that's going to be our first definition of today. And that is, what is a locus? So a locus is the set of points that satisfy one or more conditions. Sometimes the set of points will make a shape. Other times the set of points will just be a couple of points. If they do make a shape, then the answer, all of our answers today will be what is the locus? And that answer will either be a named shape or as best as you can get. Sometimes it's hard to, hey, if it makes a triangle, that's easy to make. If it makes a circle, that's easy to make. That's easy to state. Sometimes you may get a shape that's a little bit more challenging to describe. By the way, the picture is the answer. You're going to be making pictures today. So we're not going to do an actual construction in the sense of how we've been doing it before, but we will be drawing things, and the answer to every problem is the drawing. Plural of locus is, it's either pronounced loci or loci, either one. Tomorrow we'll do loci or loci problems. Today we're going to do locus problems. And if it's just a locus problem, it's going to be one condition. So if it's more than one conditions, we usually say the word loci or loci. All right, shouldn't make much sense to you right now, but it will. We're going to do 4 examples. 2 of them I'll do for you, and then I'll have you do 2 of them yourself. All right, so let's get to it. So it sounds very complicated, and sometimes it is. I'll just say Loci Loci problems are usually very complicated, but locus problems are pretty straightforward. And today they should be fairly easy. So I'm gonna give you 2 examples, and then I'll have you do 2 examples. All right. So now this is going to look like a proof. In a locus problem, you have a given. They got to tell you the set of parameters that start off the problem. So let's see, how does this problem start off? Oh, I got point A. Well, that's easy. That's easy to draw too. And let's see what the conditions are. Now, if it's a Loci problem, you're going to have more than one conditions. But here I'm just going to give you one conditions. And the condition is the set of points on a plane 1 centimeter away from point A. So what do you want to do with this? Well, I want you to come up, what is the shape that would make? So the answer is either the picture or in words. I'm going to give you both. So let's see, well, how do you do it? So you start off with a given, draw the given. So the given is a point A. I can do that. There's point A. The condition is the set of points on a plane. Okay, so what does that mean on a plane? That means in 2 dimensions, so they're all on the same flat surface, 1 centimeter away from point A. So all the points that are 1 centimeter away from point A. So if I were to draw that, there's a point 1 centimeter away, there's a point 1 centimeter away. And if you were to continue this problem and draw all the points that are 1 centimeter away, you'd wind up in red with the locus. So what's the locus? Well, it's either the picture there in red or in words, and I can describe this one pretty well. That's a circle with a radius of 1, or a circle with a diameter of 2, either one. So that is what you will be doing today. You will start off with a given. You will read a set of conditions. It'll just be one condition, and you will draw what that combination of the given and the condition makes. All right, let's do another one. Example number 2. My given is point A. It sounds familiar. And my condition looks exactly like the previous one. Is this a mistake? Well, let me go back to the previous one. Here's the previous one. Well, what's the difference? Oh, I see it. It says the set of points on a plane, and this one, the next one, just says the points that are 1 centimeter away. So if we consider this thing, we still start off with point A. We still have all those points that are a centimeter away. But if I'm not restricted to a plane, then my points could go in and out from point A, and that would make a sphere. So a sphere would be the set of points 1 centimeter away from A. So I could be a bit more descriptive and say a sphere with a radius of 1 centimeters, or in this case, sphere A with a centimeter or a radius of 1 centimeter, diameter 2 if you prefer, but that would be my locus. So let's take a quick break right here and just see what just happened in the last 2 examples. Quick note. So some of these are going to be in 2 dimensions. Some of them will be in 3 dimensions. Well, how do you know whether they want me to consider 2 dimensions or 3 dimensions? Well, it's the words on a plane. So some of the problems tonight will be on a plane. Some of them will not. Make sure you read them carefully. Sometimes it'll be in the instructions for the specific problem. Sometimes it'll be in the dark bold. It says questions 1 through 4, consider all your locus to be on a plane or not on a plane. And it says not on a plane, or it leaves out on a plane, then it's in 3 dimensions. Hopefully that made sense. So I said the shortest class of the year. We've already done 2 examples. We got 2 left. So here we go. I'd like you to pause and then see if you can figure this out, and then come back and let's see if you got it. Okay, so let's see what it says. It says my given is a segment AB, and my condition is a set of points on a plane. So we're in 2 dimensions, 1 centimeter away. All right, so I could draw a segment AB. I don't know how long it is, but I'll just draw a generic AB. And let's see, if I'm a centimeter away from AB, that means I'm either above it or below it. So it looks to me like it would be 2 parallel lines. Seems something's missing here. What's missing? Oh, the endpoints of A and B. Now, I could still be a centimeter away from B and not be on one of those red segments, right? So I could be right there and still be a centimeter away from B, and I'm not on one of those parallel segments, so maybe it's not 2 parallel segments. Well, if I draw another one 1 centimeter away, it turns out I'm going to make not a circle. I had to draw a circle. But it doesn't really make a circle. Let me erase the part it doesn't make. So this point right here, even though it's a centimeter away from here, it's not a centimeter away from here. So what I would have to do is I would have to erase all the parts that aren't a centimeter away. And so that erasing would be all of this right here. So you'd wind up with a semicircle from here all the way around to here, and that would be on both ends. Let me make it a little bit neater here and show you what you would get. You would get that right there. So what is that? Well, you can see the words I put there. A hot dog slice. Some people would want to write the word oval. It's not an oval because we got flat surface or flat segment right there. So it's not made of an oval, but I get your idea if you said oval. Oval would be technically the wrong answer. So I don't have a word to describe this right here. So hot dog slice, or just the picture itself with some arrows pointed to it, would be fine. All right, 3 down, 1 to go. Here's the last one. And it looks like the previous one. So what's the difference? Once again, we're not on a plane. So this one would be in 3 dimensions. So I would, pause and see if you can figure this out. Figure it out? Okay, so let's see. So I would still be a centimeter away above and below, but it would be in a 3 dimensions, or it'd be in 3 dimensions. So therefore, it wouldn't be parallel segments. It would be a cylinder, right? If you can imagine, if you're 1 centimeter away from AB and you wrap it around it in 3 dimensions, that would trace out a cylinder. But what about the endpoints? Well, it wouldn't be a circle. It would be the three-dimensional equivalent of a circle. So that would be a sphere. So on each end there, you wouldn't have a sphere. You would have a hemisphere. And yes, I drew a full sphere. I just couldn't, I couldn't find anything that would give me a sphere drawn. So just ignore half of that sphere and kind of get the idea. So what is that shape? A cylinder with two hemispheres on the end. Some people would call this a pill, maybe, or capsule, like a medicine capsule. Right? That would make sense. If we call the other one a hot dog slice, then maybe this is the entire hot dog, right? So a higher hot dog that has a diameter of 2 centimeters or a radius of 1 centimeter. You could go with any of that, or you could go with the picture itself. All right, so believe it or not, that's it for today's class. Let's see, tomorrow's class will be, or tomorrow and the next day will be on loci problems or loci problems. So it's going to be multiple conditions. And then we'll do some constructions to end things up. And those will also be short classes. So pretty easy end to the construction chapter. Remember I said the construction chapter is the easiest chapter. All right, homework will look something like this. Notice that you're given here, number 2, it says draw 2 parallel lines, K and L. That would be your given. On number 3, draw an angle. That's your given. And then A, B, C, D lists your condition. All right. All right, so I'll end up showing you the homework slide, but that is it for today. Good luck with your homework. If you're running into any problems, drop me an email.